Good afternoon, all. Last class we discussed about Booth algorithm. Today we are going to study about modified Booth algorithm. Here the advantage is the main objective. Otherwise, that is the advantage to reduce the digits, number of digits of the multiplier. Right? In straightforward multiplication, what will happen? If there are 5 digits in the multiplier, so you'll have 5 products. That is, you'll be calling them as supplicants. We'll be having 5 supplicants, and you have to add them, and you'll have 5. More than that, we have to have 5 multiplications. 5 multiplications and 1 addition at last. Here the objective is to reduce the number of multiplications. So the reduction of number of multiplications will contribute a lot in terms of space, time, and while designing a circuit. Am I correct? I will discuss about that during the end of the class. You'll see how it is reduced. It will be reduced by n by 2. If we have 6 digits are there in the multiplier, it may be reduced to 3. So you are reducing the number of multiplication by 2. It will be n. If it is n will become n by 2, hardly n by 2. So the summons will reduce. The number of summons will be coming down. If it comes down, it won't affect the addition to a greater extent, but it reduces the number of multiplications. I hope you know the significance of multiplication in deciding the complexity, any complexity, whether it is space complexity or time complexity or architectural design complexity, whatever be the complexity, it will contribute a lot, maybe in the negative way, in our point of view. So how it is being done? We are doing a recoding technique. First, you will be doing pair recoding. Then we will have a table as shown like this. So you will be pairing. So we are reducing. Am I correct? Maybe n to n by 2. Reducing n number of digits in the multiplier into n by 2. We are reducing. So how to reduce? That is called recoding. We are doing some process that is called recoding. By this recoding process, we are reducing. So how to do the recoding? That is given. The pair recoding is given. So you will have a look on this pair recoding. Above this, the next table, which is given in the next slide, is very important. I showed you, no? This table is important. I will show you what is that table. Here you can see the digits or positions of the multiplier. So how it will start in a binary? Start with 0. It is LSB. X0 is LSB, least significant bit. So it will start from X0, then X1, X2, X3, it goes from least significant bit. And we are adding X minus 1, right hand side of X0. In Booth's algorithm, we had Q0, Q1, Q2, Q3 towards the left hand side and Q minus 1 in the right hand side. And we assumed 0. In the algorithm itself, it is given that that Q minus 1 is known as 0. Keeping that as 0, we started the multiplication in Booth's algorithm. Okay, so it is X minus 1. So you have to combine 3 bits and you have to make it into 1 bit actually. From 3 bit, you are making it to 1 bit. This is X0 or I. If it is I, it is I plus 1, it is I minus 1. Am I correct? If this is I, this is for X2 is I, then X3 is I plus 1, X1 will become I minus 1. In that way, you have to combine, and from 3 you can get 1, and thereby you are reducing n number of digits into n by 2 number of digits. It is only done for over the multiplier. You don't disturb the multiplicand. Okay. This is the table. So I told you I plus 1, I minus 1. Okay. I plus 1, I minus 1. So this is these three combinations. So based on these different combinations, you have to make this multiplication. You don't worry about this pair recording. That is intermediate one. You don't need to worry about that. Wait a minute. So you no need to worry about that bit. You have to worry about, you have to look into I plus 1 and I minus 1. If this combo is 0, 0, 0 means you have to multiply the multiplicand by 0. 0, 0, 1 means you have to multiply the multiplicand by plus 1, then and so on. It goes, right? So this you have to keep in mind, or you got to write in a piece of paper even before the exam starts. You can, because it is an open book test, and it is better to write in the right hand side of the paper. So this table is important. See on exam. So 13 minus 6. So how to deal with negative numbers while performing multiplication or addition or anything? All of us know. And in both multiplication also, I told how you have to do. You have to take 2's complement. If it is minus 6, you have to take 2's complement of 6. Or how will you take 2's complement? First, you have to take 1's complement by interchanging ones with these zeros and zeros with 1. By substituting zeros with 1s and 1s with 0, it will give you the 1's complement. Now you have to add 1 with the 1's complement. It will give you the 2's complement. Okay, so you have got it. So here 0, 1, 1, 0, 1 is the multiplicand. 1, 1, 0, 1, 0 is the multiplier. Now you have to work on the multiplier. How to work on the multiplier? You have to work like this. You have to write the digits of multiplier like this, and you have to combine 3 digits from here. X minus 1 is very important. And you have to refer this table. By referring this table, you have to decide which number has to be multiplied with the multiplicand instead of the multiplier. Wait a minute. I will upload another PPT.
So for CAT 1, is it necessary to refer to the book, or will the notes be fine?
Yes. So what you have to do first? We have to work on this multiplier, and you have to combine and get the which multiplicand. Here it is given. I will show you how. Yes.
So for CAT 1, is it enough to do PPTs, or we really need to do the book?
I told minimum 3 times I have talked about that. What did you do in the class? Did you sleep in the class when I talked about that?
No, sir. Like.
Wait, let me complete. I am teaching you a problem. You wait. We'll discuss after the class.
Okay, sir.
So what is the multiplier? 1 1 0 1 0. 1 1 0 1 0. So this 0 is 1 0 I have added, that is I minus 1 by default. In like the same way, in that booth multiplication we had q minus 1 as 0. I hope all of you remember. And here I minus 1 is 0, and we are combining these 3 digits. How? In this fashion, x minus 1 x0 x1, here it is given. So the actual multiplier will start from x0 only as LSB. Okay, so here you can see 0 I have added. So 0 1 0 0, I have combined these 3. What is 1 0 0? What is 1 0 0 means you have to multiply with minus 2. Okay, what's the next one? Then combine these 3. For combining these 3, you have to start from here, from right to left. 1 0 1. What is 1 0 1? 1 0 1 minus 1. So you have to multiply with minus 1. I have added minus 1 here. Then 1 1. Here I have added 1. It is a sign bit. So you can extend the sign bit. Right? You can this one is a sign bit because it is a minus 6. It will be a sign bit. If it is 0 there, sign bit as 0 means you can put 0 here. You have to put 0 here. So 1 1 1. What is 1 1 1? We can see here 1 1 1 0 into m. M is multiplicand. So instead of multiplying the multiplicand with 1 1 0 1 0, we are going to multiply only with 0 minus 1 and minus 2 as shown here. This is for this one, for this one, for this one. Minus 2 minus 1 0. Okay. Now before going for multiplication, I will show you another one. How to multiply. All of us know multiplication with 1, what to do we know. With 0, we know what will be the output. For minus 1, you have to take 2's complement. This also I hope all of you know. It will come in the digital electronics itself. If you want to multiply a number with minus 1, you have to take the 2's complement of the multiplicand. So plus 2 minus 2 may be new to you. If you have to multiply with plus 2, you have to put 0 in the LSB. For example, the multiplicand is 1 1, and you have to multiply this with plus 2 means the answer is 0 in the LSB, 0 in the LSB, then 1 1. So if I read normal direction, if you read, it will be 1 1 0. Understood? If the multiplicand is 1 1 1, and if you have to multiply it with 2 means the answer will be 1 1 1 0. Right? If it is minus 2, if you want to perform minus 2, you have to shift left the multiplicand by 1 bit. So those who have not referred the PDF, I asked all of you to refer that PDF as well as to go through the video which I have shared, because you may, during the class it will look like very easy. After the class you may forget the steps for both Booth's algorithm as well as the modified Booth algorithm. Okay, so please refer. For modified Booth algorithm, I have given 3 links. It is very elaborate. The third video is very important. First 2, if you want, you can refer, but you go through the video. Nothing wrong in that. But these steps are enough to solve the problem. So you please refer how to perform the shifting, left, shift right, both logically and arithmetically. And then you have to take 2's complement. That's all. And you have to add the summons. You will get the final answer. And one important thing, there are 3 ways of multiplication. One is straightforward multiplication, like you will be doing on a decimal number. Next one is Booth's algorithm, and next one is modified Booth's algorithm. But the output of all the 3 will be same. Our aim is to reduce the summons, to reduce the multiplication, to reduce the addition, whatever may be the reason. But the answer is same. Why I am saying, so when it is asked in the exam or an assignment, the steps are very important, because answer is known one. Answer is very well known one. Even you can try with the straightforward method and write the answer. Don't do that. Steps, each and every steps are very important in both Booth's algorithm and modified Booth algorithm. Come back. So here we have decided to multiply with 0, minus 1 and minus 2. So it is first it is minus 2. So minus 2, how it is done? Shift left m by 1 bit and take 2's complement. So you please refer that PDF. There it is given the shift left how to do. I explained you shift right when I taught you modified Booth's algorithm. The same way here you have to do shift left. Then you have to take the 2's complement for -2. For -1 you have to take 2's complement of this number. For 0 you can add 0 over. But next thing is very important, whether to you can see blue color digits, whether to add 1 or 0 here. If it is a negative number, you extend it with the 1 as a sign bit. If it is a positive number, you have to put 0 as and extend. Okay, you have to extend with these numbers. So here it is 0 0 will come 2 1 2 3 4 5. So if here from here it will come. So to that extent you can add and get the answer. If you want to cross verify in the side by side, you can perform straightforward multiplication and keep with you to cross verify the answer. Okay, to the extent sufficient number of digits can be added. Okay, I repeat from the first step. Only 3 steps or 4 steps if you want to consider that also as a step. Which one? The negation. So the numbers will be given either binary or decimal. If it is negative number, it is common for both Booth's algorithm and modified Booth's algorithm. Okay, so what you have to do, you have to make it as a 2's complement. If negative number is given, for example, -15 given means you have to convert it into binary, then you have to convert it into 1's complement, then by adding 1 you can convert it into 2's complement. So it's the first step for both algorithms, for both modified Booth as well as the Booth algorithm, right? Next one, you have to take the multiplier and you have to do this one. You have to add 0 in the right hand side and combine 3 3 3. So it is always desirable to have even number. If not, you can extend the sign bit. If you want to, you have to have 3 numbers, right? 3 numbers you have to club together to get 1 number. So from the right hand side, this 0 should be added. You should not miss this 0 and put the 0 in the answer sheet, and whether it is exam or assignment, make it as in a square so that it is easier for you as well as the faculty to evaluate. Then you combine 3 3 3 3 and you get it, and refer this one and do the multiplication, whether it is -1 or +2 or -2. By doing this method, if it is -1, take 2's complement and write and extend the bit. You can extend any number of bits in the left hand side. 1 or 0 both are same if it is sign bit. Don't change the value. And if it is +2, put 0 in the LSB as I told. In the video which I have shared, +2 is there. +2 is coming, so you will understand how to add. I have told, right, 0 how to add in the LSB. If you number is 1 1 and if you want to multiply with +2 means answer will be 1 1 0. 0 is in the LSB and write the multiplicand as it is. For -2 you have to perform shift left first and then take the 1 bit shift left, then you have to perform 2's complement. And you can, if you want, if it is needed, you can add or extend the sign bit in the left hand side and you have to add. And if it is needed, you can do it in a pencil, it in the straightforward multiplication, and you can add altogether. Okay, now you have any doubt, you ask me. You please, I refer it once again, either you watch the video of mine or video which I have given. So you will get some 1 or 2 different combinations. You watch, I have updated that document with 3 more links. So totally 1 link for Booth's algorithm, 3 links for modified Booth's algorithm. And it is expanded one. I have taught you only the required one. I didn't, because in the first video they have explained this one. It is not required. And the second video they explained this one. That is also not required. The third video they have given an example. They have explained with an example. But this you should memorize. If it is a closed book test, you should memorize this combination. This table is very important, as like the flow chart of the Booth's algorithm. Then you follow the steps which I have told. Take the multiplier and combine, add the 0 in the right hand side. Then that is I minus 1 bit. Then you combine 3, 3, 3. From where to choose 3, that is very important. When you see, it will look like very easy. Some will start with here. Some will miss this and start with here. So it will become a mistake. So you please check this one. Here you can see. Right? From x minus 1 to x1, x1 to x3, x3 to x5, x5 to x7, x7 to x9, and so on. Right? And then how to multiply, I have given. I have written and given. Take 2's complement for minus 1. And I hope all these things you know. Please refer that. That for the, you work it out. You work at least one problem by your hand. Maybe the problem which I have not given in the video or in the class, so that you will get some doubts, means you can clarify. Computer science students, the problems may not be much there in the subjects. So by seeing or reading, it won't work, right? So this is these are the steps. Now you can ask me if you have a doubt, you can ask. So I will tell one thing, you please go through the video as well as you please work it out. Otherwise, you may commit a mistake. But answer is known one. Don't do the back work. Steps are very, very important here. Don't go by steps. But that steps is very important in Booth's algorithm. If there is 5 bits in the multiplier, means 5 steps, 5 iterations should be there, should be written very clearly with what you have done in the right hand side. You have to write what you have done in the right hand side. I repeat, you should write as it is given in the PPT, then the PDF file. You have to write. If you are doing a minus m, you have to write. I'm talking about Booth's algorithm. If you do a plus m, you have to write. If you do right shift alone, you have to write. So I will share the syllabus now, and I will explain you about the portions of Cat 1. Last class, somebody asked. If time permits, I will type in a word file and share with you. And another word file with I think the name of the Booth's algorithm, web reference, like that. One word file was shared yesterday, the last class. I don't know how many of you referred that. I have added 3 more links there and I have updated. So please refer it. Wait a minute, I will show the syllabus now. First module full, right? Introduction to computer systems, overview of organization and architecture, functional components of computer, that is IAS computers and all will come, right? Registers and register files. In registers and register files and this and all, you may expect question about the registers and the working of the entire system. How opcode fetch is done, how it is fetching the opcode from the memory, and how it is getting the value from the memory location to perform any arithmetic operation, any operation, how it is stored in the memory again. Like that, you can expect questions. Interconnection of components, and from the performance of the processor, you can expect numericals. You can expect numericals from the performance of processor. We have discussed. You refer the PPT. Some 2 or 3 formula are there. Refer that. And in the second module, it is up to modified booths. The second module. So fixed point representation of numbers means the decimal point is fixed, and by default it will come floating point also. Then algorithms for arithmetic operations. So arithmetic operations means automatically 1's complement, 2's complement will come for subtraction. For addition, no problem. So addition of negative numbers means once again 1's complement and 2's complement will come, right? So 1's complement, 2's complement, and then addition, subtraction, multiplication. Multiplication, 3 types are there: straightforward, Booth's algorithm, and modified Booth's algorithm. So here you may expect numericals from these arithmetic operations in general. Even it is full of numericals only in this second module. It may be, numericals will be there in the representation of numbers, fixed point or floating point. You can expect numerical from addition, subtraction, multiplication, division, one's complement, two's complement. Sorry, division is not there. Up to modified booths. Up to this. Come to third module. Third module up to subroutine call and return mechanisms. I have already talked about this, how it is called, what is the use of program counter and stack pointers. What is the use of program counter? It is a register in which the address of the next instruction which is going to be executed will be stored. That is called what is that? Program counter. It will help a lot while performing this subroutine. Anyway, I will teach you in the next class. So come the instruction set architecture and the instruction format. Here some twisted questions can be asked. The impact of instruction set and why a processor has its own instruction set. As I told many times, right? So every processor will have their own instruction set, unlike the personal computer or high-level language program. And instruction types, various types of instructions we have discussed, and various type of addressing modes: 0 address, 1 address, 2 address, 3 address instruction, operand also, 0 operand, 1 operand, 2 operand, 3 operand, and stack. What is that? Stack point computer, right? It is how the expression evaluation is done using that stack in a computer which doesn't accepts any operands, but it evaluate the expression using stack. That is there. So phases of instruction cycle only I told in the beginning of the model, that is opcode, fetch, operand, and how it is done. And assembly language programming means simple programs can be asked, not a very complex program, maybe addition, subtraction, multiplication, division, how it is reading the value from the registers and doing the arithmetic operation and storing the result to the memory once again, from the register to the memory. Initially it will store from the memory to the register. So first one is LDA, the last one is STA, right? Then conditional branching, that also we discussed, and that is assembly language programming. Very simple. You should be able to make basic arithmetic operations, not like a very big one like stepper motor interface or something. So subroutine call and return I have already told. It is like a function. A control will go to the subprogram, and the end of the subprogram there will be a return statement. It is must, unlike your C program. In C program, we know need to return is to return only the output. In the functions you should have studied return, that is functions in C and C++ program. There the return is only to return the output. If you are adding two numbers, means C is equal to A plus B, return C. But here return means control. The entire control will go there in the subprogram. Once it encounters return statement, it will come back to the main program and it will continue. How it will continue the next instruction from which it left, using the program counter. Program counter will have the next instruction, address of the next instruction. Sorry. So this is about the portion to be covered. And next I come to the question which asked by one student. PPT, I told this many times. Even in the very first class I told PPTs are teaching aid of faculty member. You cannot consider always as they are the notes. I have given two books. I have uploaded two books, one in DTOP, another in the MS Teams. And I have talked about another book also. It is a huge volume. The size are very big, so I was not able to upload. For your convenience and as per the syllabus, you have to refer the textbook. I am telling this from the beginning, and you minimum 3 or 4 times I have told. I have talked about the significance or importance of reading textbook, not only for this subject, for any course, any BTech program. It is always advisable to read the textbook prescribed in the syllabus, not with the PPT. PPT, that's what I told. PPT is a aid. If a faculty member is very strong in a subject, he will talk with only one point for 1 hour. If he wants to add more, he can add more. So you should keep that in mind. It doesn't mean that you should rule out. You should not refer the PPT. You can refer the PPT. You can refer. You have to refer the book, since it is an open book test. If you take the hard copy of the PPT alone and and write what is given in the PPT and claim that I have copied from PPT means I won't give full marks. This also I told very clearly. It's open book test. You have to write the exact answer. You should understand the question first. That is very important. It is open book test. So you have to understand the question very clearly and answer only the question which has been asked. Should not do brute force or beating around the bush. If the question is of a 5 sentence and you do not know which 5 sentences you have to take from the book, should not write 15 sentences, assuming that the faculty will award those 5 correct sentences. No, it's not like that. So that is one point. Second point, for any question, even if it is a theory questions, maybe one question, maybe somewhat theory question. So you should not copy paste from the PPT or book. Book I cannot say because book it will be sentences will be there. In the PPT it will not be a complete sentence. Bullet points will be there. You should not write what is there in the PPT and say that, sir, I have written what you have written in the PPT. That PPT is only to take class. If points are there means you have to make it into a sentence. Understand? You have to convert the points which is given in the PPT into a sentence. That too, the sentence which is relevant to the question. Okay, sir, I do not know how to convert it into a sentence and I do not know which is relevant to the question. So I have written exactly what is there in the PPT means I will give marks. I won't put 0. But don't claim after the evaluation that I have written the PPT, what is there in the PPT, so give me full marks. That is not possible since it is an open book test. Even if it is a closed book test, you are not supposed to write what is exactly given in the PPT, but you won't because you may not have access to the PPT. So I hope you got my point. Question will be slightly twisted. Or numericals means no problem. If you will simply do the numericals. The theory questions, please don't reproduce the PPT, any PPT. You should write in sentences, complete sentences. If you write words and bullets and phrases, means it may lead to reduction of marks. Understand? So that's all. If you are having any doubt regarding this portions or nature of questions or how to answer and so on, you can ask me. I can clear your doubts. And for both the algorithms, boosts and modified boosts, please refer it. Please go through and go through the video or my video or the YouTube video. And because you may think it is easy, but at that time you cannot refer the video. It will consume more time. Then once it is given, you have to start doing the work. Yes, you can ask me if you have any doubt.
So, where have you given the video link?
I have uploaded one Word file in the file sections of Microsoft Teams.
Okay, sir.
All the PPTs are there in the file section of. So if you are able, if you have capacity to develop the points which are there in the PPT, even I have done with one PPT, one slide. I have talked about 30 minutes. So if you can develop the PPT into sentences to 4 slides into 4 pages, you can refer PPT. Okay, wait, I'll give you attendance. You can mark the attendance now. All of you mark your attendance. Thank you. I will post DA questions before CAT 1.
Thank you, sir.
Okay, sir. So the deadline will be the same as on VTOP, right?
Yes, it is there. It is, you have comfortable time.
Okay, sir. Thank you, sir.
Thank you, sir.
அது இது பார்த்தேன் ஆல்ட்ரேஷனு. எப்படி கொடுக்கணும்? 2 to 4 to உங்களுக்கு எப்போ கொடுக்குறது? என்னைக்கு கொடுக்குறது? ஆமா, மண்டே வந்து எனக்கு வந்து சண்டே மண்டே வந்து 2 to 4 நீங்க எடுக்கணும். அப்புறம் நான் வந்து சரி. Thursday என்ன கிழமை? என்ன டேட்? 15th 16th
ஆமா சார், 16 செப்டம்பர் சார்.
16 வந்து 8:30 இருக்கு இல்லையா?
ஆமா, எடுத்தீங்கன்னா நான் 10 மணிக்கு எனக்கு அடுத்த டியூட்டி 9 வரைக்கும் சரி. 10 மணில இருந்து 12 மணிக்கு டியூட்டி இருக்கு. அதை என்னன்னா நீங்க பாருங்க, நான் எடுத்துக்கிறேன். நான் ஓகே.
எனக்கு வந்து 13ஆம் தேதி மத்தியானம்.
ஆமா, உங்களோட 13ஆம் தேதி டியூட்டி எனக்கு கொடுங்க சார். இல்ல, ஆமா 13ஆம் தேதி.
உங்களோடது 16th வந்து
16th
மார்னிங் டியூட்டி. ஓகே, நான் அனுப்புறேன். இப்போ கொடுங்க. ஏன்னா நைட்டு 11:30 தான் முடிஞ்சிடும் சொன்னாங்க. பாருங்க, ஒரு வாட்டி செக் பண்ணிட்டு கொடுங்க. நான் கரெக்டாக கொடுத்துருக்கேன் நான். ஓகே, தேங்க்யூ. கொடுத்துட்டேன் பாருங்க, கரெக்டாக கொடுத்துருக்கேன். என் இதையும் பாருங்க, உங்க இதையும் பாருங்க. சரி.